All right, hello everyone, how are you all doing? So yeah, today I will be attempting a CodeChef contest and this is SnackDown pre-elimination round. Now the thing about this round is that only 500 people will be making it through to the next round. So like for as many people that are giving this contest, you will have to remain in top 500 in order to qualify to the next round. So yeah, I mean time would be important here. It is not just about solving a lot of problems. It is also about maintaining that speed here. And yeah, I mean, let's just see how this one goes. Apart from that, I also have a new mic today. So this is like a Boya mic, and let's see if the sound quality is better today. I am hoping it is better. Yeah, let's begin now. Okay, so we have around 7 tasks. Cool. What about this part? Are all of these to be submitted? I am not sure. Okay, let's see. Yeah, maybe we have to just solve all of them. Anyway, let's begin from the first section. For a given array of length at least 3, let's define its weight as the largest value. Okay. Weight as the largest value bi minus bj into bj minus bk. Overall possible triplets I, j, k, with I is not equal to j, j is not equal to k, k is not equal to I. Fine. Okay. You've also been given a sorted array a1, a2, so on up till an, and calculate the sum of weights of all contiguous subarrays of a of length at least 3. That is, count the sum of weights of subarray. Okay. So if I'm counting the weight of a subarray, what exactly is it? It is the largest value of bi minus bj into bj minus bk. Okay. So if you talk about the largest value, then yeah. For example, if I have 3 elements, I will be defining a partition point. And there will be one side, then there will be one side. Because this whole array is sorted, so if I am defining a subarray and I am defining its weight, then it will be sort of like a partition. I'm partitioning at a point and then I'm taking the product of these 2 elements. So if I talk about the partition, if I have something like 9 into 2, that is 18. But if I take 5 into 5, that would be much bigger, right? So I will be partitioning at the middle point. Cool. So I guess this is fine. There is not much to be done here. 6,000, this should be fine. Yeah. So here I'm defining my subarrays. So it has to be of length at least 3, so I'll be doing it from I plus 2. Right, now I have to define a middle point. So int middle equals to j plus I by 2, right? Now if I'm saying j plus I by 2, if I have 0, then I have 1 and then I have 2. So I am saying that you take the partition of okay. So if I have 3 elements, I'm basically defining the middle. Okay, let me just open my charging here. Right. So when I'm saying I have 3 elements, I'm basically moving to the second one, the middle one. So I have 0 plus 2 divided by 2, which will be 1. When I have 4 elements, I will be looking at both of these values, right? So I'll be doing 4 by 2, which will be 2. Okay. Minus 1. Okay, so these are the 2 points, and then I'm defining my answer. Val1 equals to ARR at mid 1 minus ARR at I into ARR at j minus ARR at mid 1. Right. Similarly, I have val2 equals to val1 comma val2. Right, let's just see. I hope this is fine. ARR was not defined. Okay, let's do this ARR. Okay, this is coming out to be different here. Length at least 3. All right. For this one, the answer is different. Right. Okay. J plus I by 2. So if I have I plus 3, like if I have 0 and I have 3, so that will be, just a minute. So if I'm having 0 and 3, this will be, okay, this had to be different. This had to be mid plus 1. Right, when I have 0 and 4, okay, let's just do it for all the 3 values. Right, let's just do this. Okay, yeah, now this is fine. Let's submit this. Okay. What is this? Wrong answer I'm getting. Calculate the sum of weight of all the contiguous subarrays of A of length at least 3. That is, count the sum of weights of arrays. Okay. Product pane. Maximum value of bi minus bj. Oh, just a minute. This is bi minus bj, and then this is bj minus bk. Okay. Yeah, this will always be positive. This is fine. But instead of that, j has to be in middle. That is fine. That is for sure. J has to be in middle. If it is on the side, then we're essentially doing some minus values, right? Yeah. So J has to be in middle. That is fine. Then where do we put it? If I have 9 into 2, that would be less than 5 into 6, right? Yeah. So I don't know. This seems to be fine. J has to be in middle. That is fine. That is fine. Why am I getting a wrong answer here? Of length at least 3. And if I have this 1, 2 and 3, is this fine? Let's see. So I'm getting 1 as the answer. And then if I had this as, if this was something like 2, 3, 4. Right, what about this one? Oh, we don't have to take the middle one. We have to take the average value. Ah, I see. We don't have to take the middle one, we have to take the average value, the one which is closest to the average. So that won't be in the middle for sure. Okay. Okay, let's just find out a middle value. Mid value equals to ARR at j plus ARR at I by 2. Right, now we have to find the closest value here, right? So how do I find this closest value? Val1 equals to, this has to be in the middle, which is fine, star lower bound of, right, so this will tell me the first value which is greater than or equal to this, right? Then what about the value which is less than or equal to this? Mid value, okay, so I have to find the value which is just smaller than this, right? So I should be doing upper bound, right? Max of, okay, so there is just 1 equals to ARR at I minus val1. Right, so here I am finding the first value which is greater than or equal to, then I am finding the first value which is less than or equal to, right? So answer plus max of answer 1 comma answer 2, right? Yeah, this should be the value. So yeah. And what about this one? If I had this 10 here, let's say 1 comma 3 comma 10, 2 into 8, this should be 2 into 7 in fact. Okay, what about this one? If I have 1 and 10, then I should be having 5. So if I have 5 here, then I have 7 here, or in fact if I have 4 here. Right, so for 1 and 10, I should be having 0 to 5 in fact. 0 to 4. For 0 to 4, yeah, 4 and 7 are fine. Yeah, this seems to be fine now. But I'm not sure if this is fine according to, the time complexity. Like this would be order of, that is like 36 into, no, this should be fine, I guess. Let's submit this. Cool. I was just confused. I just switched to this tab and I was getting a wrong answer here, so that was like insane. Anyway, we're done with the first problem. Let's move to the second one. It actually took up quite a lot of time, but yeah, I guess the rank should be fine right now. Like only 216 people have solved it, so right now I am doing totally fine. Let's move to the second one. You're given a positive integer k and an array a consisting of n non-negative integers. Okay, you're given a positive integer k and an array A consisting of n non-negative integers. Find the lexicographically smallest subsequence B that satisfies the following condition. We can obtain B by rearranging the elements in A. Okay, so smallest subsequence B. Okay, so ideally what we are saying is that just pick up any elements, arrange them however you like. Right, the length of the longest non-decreasing subsequence of B is equal to k. Length of non-decreasing subsequence. Okay, almost like length of increasing subsequence. Right, that should be equal to k. Okay, so what do we have to print? The output the array B in a single line with a space between two consecutive elements. Oh, okay. All we are saying is that the length of the longest increasing subsequence should be equal to k. Okay, so I mean we can arrange this array A however we like. That is the first thing. Right, I can even define a DP, I guess. Like I am on the ith element, you know. Oh no, we cannot define a DP here because the order matters here. Okay. So if I'm already saying that I have to pick k elements, why shouldn't I only pick k elements? That is the question. I should be picking only exactly k elements, right? That is a subsequence, fine. So, okay, let me just read the problem statement once again. You're given a positive integer, and also let me just see. Everything is fine here. Cool. You're given a positive integer k and an array A consisting of n non-negative integers. Find the lexicographically smallest subsequence. Oh, we have to find the lexicographically smallest. I see. So why not just sort this array A first of all? That satisfies the following conditions. We can lexicographically smallest. We can obtain B by rearranging the elements in A. I am not sure what does this mean here. Okay, so we have to rearrange A into B. This is fine. And then inside B, we also have to rearrange it such that B is lexicographically smallest. And then we have to check, if the length of non-decreasing subsequence of B is equal to k or not. Fine. So why not just sort the array A first of all, pick up the first k elements that are sort of, increasing. Then we are talking about the last few elements, right? So, okay. So if you talk about the last k elements as such, why not put them in decreasing order? Right? Put them in decreasing order just before the last element. Okay, this seems to be a tough problem. Lexicographically smallest subsequence of B. No, lexicographically smallest subsequence B we have to find such that the length of the longest non-decreasing subsequence in B is equal to K. Okay. So first of all, my first intuition is to first of all sort the array A. It does not harm us to sort the array A, first of all. Then we have to make sure that the length of the longest subsequence is equal to K. Alright, initially the length of the longest subsequence is equal to N. Fine. Now let's say K is equal to N minus 1. Okay, yeah. Then where do I put the last element? Let's say the last two elements are something like this. Let's open OneNote. Yeah. So let's say we have an array like this, 1, 2, 3, and 4, 4. And the length of the longest subsequence that you want is equal to 4. Right. Now it is currently 5. Now even if I replace these two, it does not, matter. But now let's say I put my 4 here. Would that be the best that I can do? Or can I do something else? I think this is the best, right? Yeah. Let's say my K was equal to also, if we had something like this, if we had something like 1, 2, 3, 3, 4, 4, and we want N minus 1. Okay, so then we can do 1, 2, 3, 4, 4, 3. So here you have this coming up, then we have this. Okay. Okay, but since this value of N is very small, this sort of gives me an idea around dp. I don't know why. Okay. Let's first of all sort this whole array. Let's say we have something like this, 1, 2, 2, 3, 3, 4, 4, 5, something like this. And then let's say we want the length of the longest subsequence to be equal to K. Okay, let's define it K like this. We have taken the first K elements, and now the last N minus K elements are also increasing right now, and they're adding up to the value. So we have to sort of remove them. Right, what about this element? Where do we put it? That is the question now. So obviously, I cannot be putting it here for sure. So I will have to put it here. Right, that is the best place that I can put it at. Cool. Now, let's say I have something like this, 1, 2, 2, 4, 3, 3, and now I have another 4. Okay. Now again the same situation is arising. Our overall K value is saturated somehow. And now what about this 4? Where do I put it? If I put it here, then this is fine. Right now it is fine. Let's say I put it here and I have another 4 now. Okay. Now where do I put it? If I put it here, okay. If I put it here, then the value would be, And why am I not putting this 4 here? I should be putting it here, right? Yeah, that would be the best considering the lexicographical order. So yeah, I can put it here. Then I have to put the next element at such a place, at the such a farthest place, such that my overall value does not exceed. That is all that is required right now. Right. So I think I can do this. This can be done even greedily. So we have n and k, and then we have a vector. Right. Now I'll first of all sort this. Now I have my answer variable, answer vector here. Okay. Cool. So I will be inserting at those places such that the answer does not exceed k. That is all I'm doing right now. Okay, fine. But how is it a guarantee that the answer will be found if there is an answer? First of all, I am maintaining the lexicographical order by choosing greedily, choosing the most greedy place to put that element. Right. Now okay, now how do I choose that greedy place? Can I do a binary search on this? Like if I'm putting an element at some place and it is not hampering my situation, then putting it at the left would also not hamper it. Putting it at the right could hamper it. So I can do a binary search on that, but that is fine. Okay. So n equals to, right. So while start is less than equal to n, right, cool. Now I have to binary search if helper mid comma answer comma k, then I'm doing found equals to max of found comma mid, right. So this is fine. Then I'm defining my helper function. So I will also have to be finding the maximum length of the longest subsequence here. So I'm doing int place, and I'm also doing okay. So I have to insert it at this place. Fine. So how do I insert at a particular place? Okay, so initially you have 10, 20, 30 and 40. Vector.begin, and I'm inserting at the third place. Okay. So at the beginning I'm inserting a 3, then I'm inserting I don't know what is this. Anyway, let's just experiment. Let's see. Okay, this is fine. Then I'm inserting at the first place. What if I insert at the 0th place? This is fine. Okay, so then I do arr.insert, and I'm also inserting a value here, right? So val, let's have it. Okay. Right, now I have to just find out the length of the longest subsequence. That is basically the longest, increasing or longest non-decreasing subsequence. Okay, now if arr@I is greater than equal to answer.back, then I do this. Okay, so then I have to find an index where I can insert it, right? Right, so this will be giving me an element which is the first increasing, right? Okay. arr@index equals to, in fact, should this be upper bound? Yeah, this should be upper bound. arr@index equals to, sorry, answer@index. Answer@index equals to arr@I. Okay, let me just see if this is fine. I'm inserting at this place first of all. Then this is my vector which will be storing the maximum, the length of the longest subsequence which is increasing or in fact non-decreasing. So I've inserted the first element, then I'm doing this. If it is greater than equal to this, then I'm just inserting it at the back. If it is not, then I'm finding the next greater element and I'm inserting it there. Fine. So let's see if this works. Okay, so we also have to do something like this, right? Answer.insert. Okay, now let's see what is the error here. N was not declared in the scope. 78. Then we have 82. Then I have arr@I. Then I'm having an error in 74 and 106. 106 is this. I'm passing this value, right? Vector. Oh, okay. This had to be K. Okay, I'm getting a -1 here. Okay, let's do some debugging of answer. Okay, so we are not getting into this one. Okay, fine. Okay, we're not even reaching this part. Okay, so initially you can insert it at the 0th place only. Then next time you can insert it at, sorry. Yeah, this should be better. 3 2 1 1 3 2 1 2 3. Okay, this seems fine. Right, let's submit this. Okay, great. Now I could have done this in order of n cube as well. That could have been fine as well. But this is fine, I guess. Yeah. Okay, quite a lot of people have solved this first problem. Let me just see. How are people from my college doing? Okay, somehow this one was not recorded yet. Anyway, let's move to the third one.